Hey everybody, welcome back to Hooks and Hoses. It's August 2025. Hope everybody's summer's going well. This is Eric Dreiman. I'm your host of the Hooks and Hoses podcast. Uh, my guest and I couldn't work out schedules for this month, so I've got a solo show going on this month. We're going to talk about um, some myths in the fire service or some traditional things that have always been thought to be correct or wrong or right in the fire service, and just talk a little bit about how those myths came to be, what they are, and some takeaways about them. So, uh, I recently taught a officer development program to a group of newly promoted lieutenants, and a lot of the conversation that I did was built around tactics and fireground decision making, um, engine company and truck company operations, and things like that. And as I went through the conversation over the course of the day, it dawned on me that a lot of the things that I was taught as a young firefighter, as a recruit, um, were traditions that had been passed down from one generation to the next, or um, were based on information and knowledge of people at the time, which was 30, 35 years ago. Um, some of those same things, as I'm talking through conversations with the folks in the class, we're still doing those things because that's the way, it's the American Fire Service. It's the way we've always done it. It's tradition. It worked for our forefathers, therefore it ought to work for us. Things like that. And so I'm just going to go through. I got 10 things here I wrote out. I'm going to be referring to my notes here. I've got down in front of me, but I've got 10 different myths that I came up with. Um, and I want to just cover those real quick. So how do these myths spread? Well, as I mentioned, some of them come straight from, um, those that came before us, and they pass information along to us. We're new, we're impressionable, we don't know anything early on in our careers. So if somebody with a bunch of time on or a bunch of rank tells us this works, or when you see this, do this, then we take those methods, those techniques, those thought processes um, for granted, because we've got people that we look up to who have more time than us. They're supposed to be smarter than us. They've got more rank than us, so they must know what they're doing, right? So some of it's that way. Some of it's just stories that get passed along around the firehouse. Um, Another thing that I think that comes into play nowadays, much more so than even probably 20 years ago, is social media. You see a clip on on a social media platform or in the news, and you see somebody um, throw a ladder to a window, or cut a vent hole, or take some glass, or stretch a hand line to a certain place, or whatever, and you see a little snippet of what happens. And sometimes those videos are posted because of successes, and sometimes they're posted because there were issues. And I think that we misinterpret, or we can not misinterpret, but misunderstand what's happening sometimes, just based upon these little snippets that we see that may only be 10 seconds long. They could be 2 minutes long, but we don't know, in some of these instances, how long the fires have been going on, what the department staffing level is. Um, Lots of different variables that we're not privy to, but we look at one little clip and say, oh, well, this building, they cut the hole here, or this building, they stretched this size hand line. Therefore, that's what I should do the next time I go to a building like that, or I see a fire condition like that. And we need to make sure that we're putting things into perspective and using context, rather than just gut feeling. Not that, your gut doesn't tell you things from time to time, but we can't speculate, right? When we get down to fighting fire, it comes down to science and physics, right? We have heat, fuel, and oxygen, the fire triangle, chemical chain reaction, if you want to add the fourth side, and then we've got time. So we know that all of those things, particularly our outdated rules, many of which were written and developed uh, prior to the inundation of synthetic fire fuels as our fire load, prior to uh, the prevalence of lightweight construction that we see across the United States. So we have to make sure that our tactics are keeping up with the technology and the science. And I think sometimes they don't always do that. So one of the things, myth number one, we've always done it this way, right? Well, we used to be able to go up on a roof and cut a vent hole, or we used to be able to crawl into a house and spend 20 or 30 minutes in there chasing fire and putting out hot spots and not having to worry about um, the structure, right? Structural integrity. Because those older homes that were built 50, 60, 80, 100 years ago were legacy construction. They were dimensional lumber, they were old growth lumber, they weren't genetically engineered lumber that's less dense. There weren't gang nails, there weren't lightweight bar joist trusses, all those sorts of things. So we can't do those same things nowadays. I always tell people that you have to look at where you're fighting your fires. Where are you going to your emergencies? If you live in a community where most of the buildings are 100 years old, and you suddenly get a new subdivision going up on the edge of town where all the houses have been built in the last 5 years, you can't fight the fires in those houses that were built 5 years ago the same way you fight fire in the houses that are over 100 years old. They're going to behave differently. They're going to structurally resist the fire differently. There's a lot of different variables that go into that. So we need to be cognizant of just because it's the way we've always done it doesn't mean that we can continue to do that. We know lightweight construction typically fails 3 to 5 times faster than legacy construction. If you work in a community that has a lot of different eras of building construction, it's important. It's important for you, whether you're a firefighter, company officer, battalion chief, or whatever rank you are, to understand the buildings in your areas. Some of the areas that I respond to, we have brand new homes that have been built in the last 3 to 5 years standing right next to homes that were built in the late 1800s, because the neighborhoods, some of the more dilapidated, rundown homes in neighborhoods get bought up, demolished by developers, and then new homes get put up in their place. So it's important to understand those things. Synthetics, as I mentioned earlier, produce hotter fires. So we can't, it used to be the old saying when I came on the fire department, we don't spray smoke. If you don't see a glow, don't open the line. And we know now, based upon the research that's been done, that we can't always do that. We know that in many instances, these synthetics, because of the heat release rate of the synthetic fuels, that smoke can be at or above its ignition temperature with temperatures in the 500-degree range. The ignition temperature for acrolein, which is one of the chemicals that's found in common smoke produced in fires today, has a ignition temperature around 450 degrees or so. So give or take 20 or 30 degrees. I don't remember the exact number off the top of my head. But when you think that gas will ignite, its ignition temperature is roughly 450 degrees. That's not even hot as your oven gets, right? And we know that our fires can be much hotter than that. So in some of these instances, we've got this smoke that's surrounding us, going past our heads. We've got this high heat. Those are circumstances where you want to hit that smoke and cool that environment down, because we know that it can go from 0 to 100 really quick, particularly if we get the fuel mixture just right. A lot of the times the only reason that this smoke is at or above its ignition temperature and it's not igniting is because there's not enough oxygen, or it's too rich, basically, right? So not to get into a whole hazmat discussion, but smoke behaves just like natural gas, gasoline. You pick acetylene, you pick your flammable product. The smoke is no different. It has a flammable range. When it gets inside that flammable range and it has the proper ignition temperature, it's going to light. It's no different than propane, gasoline vapors, whatever the case might be. So we need to be cognizant of that. It's good to keep tradition alive. Tradition informs us. It tells us the way we've done things, what's worked in the past. But just because it's worked in the past doesn't mean that it's going to work moving forward, right? So we have to take what we're learning with the research and the science coming out of UL and NIST and FSRI and apply that to the modern fireground and still hold on to those traditions. I think there's plenty of traditions that are still worth holding on to. I'm not ready to throw the baby out with the bathwater here, but we do need to make sure that we're weighing uh, the way we're doing some of our things and making sure that the way we've done it in the past isn't just because, well, it was cool, that's how we've always done it. So, or it was based upon fighting fires when they were fighting them with synthetic. There were no synthetics or very few synthetics, and they were fighting fires in legacy buildings. So it's important to understand that. Um, another one that I came up with. It's not. It is a fireground one, I guess, but it's more about being around the firehouse and taking care of yourself. Is having clean gear. Um, we know that, and there's a big emphasis on it here in Indianapolis where I work. But there was a white paper put out a few years back about cancer in firefighters. We know that our life expectancy is shorter because of all the different, partly because of the toxins we're exposed to. Um, but it's important for us to keep our gear clean. Everybody wants to look like they've been to hell and back and they've done all this firefighting and all that sort of stuff, and that's great. Um, there's nothing wrong with wanting to have a good reputation, being considered a good fireman, and being looked upon as somebody who knows how to do the job. But you don't have to run around in nasty, dirty gear in order to do it. The fact that a lot of fire departments, I realize it's not universal, but a lot of fire departments are providing their folks with 2 sets of fire gear. I know a lot of fire departments have gear washers, or they send the gear off to be laundered if it needs to be laundered. Um, and even a lot of departments are providing or mandating, or they have policies that say we're going to decon on the fire scene, right? Um, Sometimes, in the middle of winter, that's a bit challenging, obviously, or if it's below freezing, and you have to take those kinds of things into consideration. But that doesn't mean we can't hose off our tools, our SCBAs, um, our boots, that sort of stuff, so that we're not tracking a lot of that stuff around. If you do a decent gross decon at a fire scene, studies have shown that you can reduce your uh, contaminants inside the fire apparatus and the firehouse by 75 to 85%, depending upon how good a job you do. So everybody wants to look salty. Everybody wants to look like they've just been to fire after fire after fire. They want to have a good reputation, but you don't have to run around with a helmet that's all burnt up with soot and insulation and everything else hanging from it. You know, Many of you probably are familiar with Vincent Dunn, who's a legend in the American Fire Service. Retired as a division chief, I believe, or deputy chief in New York City. I'm not sure if it was earlier this year or late last year. I kind of lost track of the date, but he had to have a large section of his forehead removed, the skin on his forehead, because he had skin cancer. And the dermatologists, the surgeons, all those sorts of folks, um, the medical folks came to the determination that more than likely the reason that he developed skin cancer in that area uh, was because of the helmet, the sweatband on the inside of his helmet, and not properly cleaning that, and just having that helmet on and taking it off, having it on, taking it off. Over the years, just exposed that portion of his forehead to those carcinogens over time, and he developed skin cancer as a direct result of that. So, it's not only the outside of our gear that gets dirty; it's the inside, like our um, sweatbands on the inside of the helmets and things like that. So, wear your gear appropriately, but decon it when you're done. We're killing more firemen with cancer than we are with just about anything else. Cancer and heart disease. When you think about how many people die at fires, there might be 10 to 20 a year that actually die from traumatic or thermal type injuries, burned, crushed, falling through a floor, running out of air and dying of asphyxiation. Um, it's not those traumatic things that are killing us anymore. It's the heart disease, it's strokes, it's poor physical fitness, and it's cancer. I've known a handful of people that have died in the line of duty over my career, and I know several dozen, if not multiple dozens, of people who have died from cancer in my career. So it's definitely something that we need to be aware of and address it appropriately. Moving on to myth number 3, ventilation. We don't vent until the fire's out. That was one that I was taught early on. And there was initially there was no. Well, I was taught two things, but um, either we don't vent if it's not vented yet, we're not going to vent, or if we've got fire showing, we're going to vent more because that's going to let the heat out. And obviously, those are both incorrect, right? We know that now, but at the time, again, young, impressionable, never been a firefighter. Got people with more time on than me, more rank than me, telling me these things and teaching these things that came out of some of them came out of the textbooks at the time. But we know that's not the case now, right? We don't run around and break windows just to let the heat out, because we know that doesn't let the heat out. We know it actually it might initially let some of the heat out, but in the long run, all it's going to do is make things worse. If we open up the structure and there's no water being put on the fire. Originally there was a study that was one of the research studies that was released that said that vertical ventilation was terrible. Vertical ventilation actually contributed to fire growth, and it had no positive impact on heat reduction inside of a structure. Those statements are woefully inaccurate. And again, that's one of those things where if you just read that, or you saw an interview with a scientist who helped conduct those tests, and that's what they said, and you didn't do your due diligence and research that, you might say, well, there it is right there. The scientists have spoken. There's absolutely no interior benefit to vertical ventilation. It does not reduce fire spread. It does not reduce temperature levels inside of a structure. Therefore, we're no longer going to do vertical ventilation at the XYZ fire department. What those researchers didn't tell you was they were studying how big the ventilation opening is in the roof, whether it was directly over the fire, whether it was distant from the fire, how big the fire was when they opened the roof, all these different things. But the one thing that they didn't tell you in all that research, or unless you did your own investigation into the research, was they never applied any water to the fire. All they did was see which size vent holes, did different things. Like if I had a 4x4 vent hole, what did it do to the fire? If I had a 2x2 or a 6x6 and it was either directly over the fire or distant from the fire, all these different things. But in those studies, they never applied water. We all know that had they applied water and the ventilation had been coordinated with the attack crew, the fire would have gotten smaller and the temperatures would have dropped, right? But they didn't do that. It's no different than open up the lid on your charcoal grill and just letting all the burgers burn off, right? You close the lid, what happens? Fire goes out, it smokes it out. But if we open the lid and we don't put any water on that or cool it down in any way, then sure, the fire is going to get bigger. But so again, it's context. We know that coordinated ventilation is very important nowadays. I always tell people there's no more patience required than a fireman with a hand tool in their hand standing next to a window, because I've got a hand tool, I've got a pike pole, I've got a Halligan bar, I've got a axe, whatever it is. Fireman sees glass, fireman has tool breaks glass. It's pretty cavemanish sometimes, but it takes patience. We have to make sure that when we're doing our fire attack and we're coordinating our ventilation with the attack crew. And we also have to make sure that when we are coordinating that ventilation, that we're ventilating in the right place. We can't just randomly willy-nilly take windows, because we know that cooling or taking a window, opening the place up, doesn't necessarily correlate directly with cooling. It only coordinates with cooling if there's water being applied to the fire. So we've got to make sure that, or we can isolate ourselves. That's the other thing. Certainly I can crawl in. If I crawl into a bedroom, I can shut that door of the bedroom and open the bedroom window and I'm going to get a cooling effect. I'm going to get lift. I'm going to get the toxic smoke out. Um, so that's another form of ventilation. That would be more venting for life versus venting for fire, right? But we're venting for life in that circumstance. The key takeaway is there, I've isolated myself. So again, it's context, right? If you hear somebody say, "Well, when I crawl in a bedroom, I'm taking all the windows as I'm searching because I know that's going to provide lift." Well, if you just do that and you don't isolate that bedroom before you take that window, then potentially you're going to get yourself jammed up because you're going to end up pulling fire to you where you don't want it. So again, it's context. But know that your ventilation has to be timed and it has to be coordinated appropriately with attack. One of the things, myth number 4, focuses around search. I mean, we know I'm really harping on this now with when I travel around and teach, and whether it's hands-on skills or I present and do lectures. When I was first taught again in the academy, we know that most of the time or at least we used to go in the front door, right? We would either follow the attack line in or the attack line would follow us in. We go in the front door, and I was taught left hand, right hand search. That was very basic then. Um, you start out, you go to the left or you go to the right, and you and your partner spread out, and you go room to room to room. And the whole goal was to search the structure, right? Pretty basic. The problem is that we're not finding victims in living rooms and family rooms and kitchens, which we know are typically going to be closer to the front door. Um, Thanks to a lot of the research that's being done by folks around the American Fire Service, um, we know that a lot of victims, the majority of our victims, are being found either in bedrooms or near means of egress. So, near windows, in hallways leading to means of egress, things like that. So, when I'm going around teaching now, and when I used to do it even before I made chief, we would oftentimes we would have to move through some of these rooms, living room, kitchen, potentially whatever, to get to stairs or get to the part of the house where the bedrooms were, certainly. And we're not going to just not physically try and search, but at the same time we're doing an expeditiously trying to get through some of those areas that are have low rate of return and get to those areas where the greatest potential fire victim location is, right? So we know regardless of time of day, we need to be focusing on bedrooms. We need to be focusing on areas near those bedrooms. And, if you can split search, if you have enough people, you can have 2 search teams. Maybe you send one search team to the bedrooms initially, whether it's through the front door and they bypass the more common areas of the house and move their way into the more private areas of the home, or the areas, the bedrooms, bathrooms, those sorts of things, and then let another group help focus and search, those more common areas that have lower rates of return. However you decide to do it would be, is ideal. Or you split search and you send one group to one area where there's bedrooms and another group where you think there might be a bedroom, but you search those real quick and then you search your way back out. There's, obviously 100 different ways to do it, but it's this idea that search starts at the front door and I'm just going to move all the way around the house before I and I may or may not come to the bedrooms. May not come to the bedrooms till last, and we know that by that point, if we haven't located those victims in a timely manner, their odds of survival are greatly diminished. Mostly because of the smoke. Not that thermal injury isn't an issue, because it can be. Certainly, fire victims have been burned, and fire victims die from thermal injury, but we know way more of them die from the smoke. All the toxic chemicals in the smoke, whether it's carbon monoxide, hydrogen cyanide, all those, just a low oxygen level. So basically they asphyxiate because there's not enough oxygen in the air to help them survive. So we need to do targeted searches when we can, highest danger areas, but also those bedrooms and those sleeping areas and those exit points from those bedrooms, rather than just going in the front door and working our way around just like we always have. So, myth number 5, interior firefighting is the only way to fight fires, right? I've heard it before, and I'm sure a lot of you have too. This didn't hit it hard from the yard. We're going in. We're aggressive. Well, I've never met any fire department ever that said, "Yeah, we don't do aggressive. We don't do anything aggressive." Right? You see all these press releases. You see statements. You see slogans people put out. Um, so many of them have the word aggressive in it. It's mind numbing. It's like, come on, we get it, right? We all want to think we're aggressive. We all want to think that we're doing the best job we can. Okay. Um, and there's more than one way to do that. I always like to tell people or ask people, hey, how many people here have ever been to a fire where the front porch was completely lit up and, and, there was fire blowing out the front door? Some people raise their hand. Sometimes it's the whole class, sometimes it's a handful, depending upon where I'm teaching or whatever. And I say, did you flow water from the outside, or did you just barge through that wall of fire and wait until you got inside that first room before you opened the hand line because you didn't want to be looked at as being a weenie or hitting it hard from the yard? And they're like, well, no, I had to hit it from the outside because of the volume of fire I had present, right? And I say, yeah, that's exactly right, right? No, would anybody in their right mind say, well, you weren't aggressive, or um, you were a wimp, or whatever term you want to use because you opened the hand line from the outside? The answer is no, right? Certainly, that's pretty straightforward. There are other maybe less straightforward. You got fire come out of a window, um, a second floor window or a rear window or something like that. Um, and a lot of these, just like I've said in the beginning of this talk, everything's in context, right? If I've got fire in a single room on the first floor, and I've got two engine companies on the scene, each with staff of 4 people, I'm going to attack that fire entirely differently than if I roll up in a rural area or a suburban area where I've got an engineer and an engine officer on a first arriving engine, and the next engine's 5 minutes out, right? I have to attack those fires entirely differently. Not because I necessarily want to. If I was arriving on that two person engine, I would love, maybe more than anything, to be able to stretch through the house and put that fire out in that room very quickly, just like the 4 guys on that four person engine company are going to do. But I can't do that because it's me and the pump operator compared to an officer, a pump operator, and 2 firefighters on a better staffed department. So again, it's all relative, but and people say, well, you're going to push fire. Well, I'm not going to disagree that I will agree that I've been in places where somebody opened a line when I was inside, and I certainly felt the temperature change. I get it. I understand that. I think that there's some of the research, you say, well, you can't push fire. Okay, I agree. You can't push fire, but what you can push are the products of combustion, right? We know smoke can be several hundred degrees. We know that even air can be several hundred degrees if it's heated by the fire. Those things can be pushed. I'm not going to argue with that. So it's important to understand. People say, "Well, I'm not going to throw water from the outside. I'm going to push smoke, or I'm going to push fire on my fire victims or the firefighters on the inside." And my statement would be, if you've got firefighters on the inside and they're making a push, then maybe I won't open the line up from the outside. Maybe if they're close to getting to the seat of the fire, then don't open the line, right? But if you haven't been able to get anybody inside yet, and I open that line up, and I know what I'm doing, and again, this is all context. This isn't me saying that you just open the line and flow water into the window and everything gets better. It's context, right? If you've never seen it done, if you don't understand how to apply it, then you're potentially going to make things worse and not better. But again, that's a class in and of itself. How to flow water, how to do, apply an exterior water stream to minimize air movement, to make sure that the water hits the ceiling in the right place to bank and deflect appropriately. Um, but interior firefighting is what we want to do if we can, but we can't always. And sometimes there are circumstances where hitting a fire from the outside, putting some water on it, cooling down that atmosphere um, from the exterior prior to make entry, or say that you've got crews who are having trouble getting in because of forcible entry challenges, or they get in the front door and it's floor to ceiling hoarding conditions, which seems to be way more prevalent nowadays than it ever was before. We may have to flow water from the outside, and it just means that you're being smart. It doesn't mean that you're being foolish or you're being lazy or you're being reckless. It just means that you're being smart. One other thing on that is wind-driven fires. We had one back this winter that we identified. My XO, my battalion aide, we call them executive officers. Sam, he and I we pulled into this fire. First engine was already on the scene, and they were stretching a hand line up the porch, um, and they were making a attempt to get into this house and attack this fire. It was a 2-story, 2.5-story, vacant, no windows in the place. There was a breeze out of the west. We happened to park on the west side of the house where we parked our vehicle, and got out. And I looked up at the house, and we almost both at the same time said, "This is a wind-driven fire." Now, had the engine company identified that, they could have flown some water from the outside and used the wind-driven fire event to help draw that water in and help feed the water where it needed to go, and get that water into the proper areas, rather than fighting their way with that crosswind coming into the house going up the front porch. So, there are times for exterior water application, and it's important to understand that. Stream selection, hose line selection, nozzle selection. I never used to be I've never really been a huge engine guy. Um, I can hold my weight, but I'm not an expert in different, hose packages and nozzle form, designs and pumping and all that sort of stuff. It's not my forte. Um, but I will tell you that there's a lot more that goes into picking hose and picking nozzles than just saying which one's the cheapest, or which one does Firefighter X recommend, or which do you sell the most of, or which has the most stars on Amazon, or however you do your research, right? Not every type of fire hose is meant to be married up with every kind of nozzle. So it's important to understand that. Some hose kinks easier than others. If you get hose that kinks real easy and you buy low pressure nozzles, that's obviously going to be a problem. If you have hose that's really stiff, and you're using higher pressure nozzles, then that obviously can compound things with kinks and getting hose around corners and stretching it and things like that. The other things to take into consideration when you think about hose from a fire stream application process, bigger isn't always better. Some departments I've seen are using 15, 16-inch orifice openings on their smoothbore nozzles, as opposed to 7 1/8, right? Well, 15/16, the back pressure on that can be substantially higher than the 7/8. It can make it hard for one or two people to hang on to, depending upon the size of the firefighter, their proficiency, and that sort of stuff. So even something as minor as just going up from 7/8 to 15/16 can make a huge difference. Other departments say, well, we're gonna up our flow rate because synthetic fuel loads and the heat release rate and all that sort of stuff, and we need to be able to punch a fire in the throat a lot quicker. So we're going to up to 2-inch hose, say. Well, now you've got 2-inch hose, whereas you did have 1.75 inch. You've got to take into consideration your staffing levels. Does my staffing level, have I got one person on that 2-inch line, or do I have two people on it, or do I have three? If I've only got one person on it, going from 1.75 inch to 2-inch with different nozzle orifice openings and things like that can create significant challenges for you. So bigger isn't always better. It's just like saying, I wouldn't pull a 2.5. Certainly I could put out a lot more fire and maybe put the fire out if I could get water on the fire, I would certainly put the fire out a lot faster if I had a 2.5 inch hand line going into a house fire than I would an 1.75 inches. But I'm sacrificing maneuverability for flow, right? So even though the 1.75 inches may not, it won't flow as much as a 2.5 typically. I can probably get that 1.75 inches where I need it a whole lot faster, which means the fire is going to go out sooner, even at a lower flow rate. So the takeaway there is bigger doesn't always mean better. Sometimes less is more. In the case of a lot of the things in the fire service, it's I always tell people it's the more technology we add to our SCBAs, the more technology that gets built into our turnout gear. There is a diminishing rate of return, right? It used to be our SCBAs were a wire frame or a plastic frame with a bottle on it, a couple of regulators, and your face piece. And now we have buddy breathers and heads up displays and built-in pass devices and all these different things, which on paper make sense and are good, but what we do in turn is we've added 10 or more pounds to the weight of our SCBAs. We've gone from 30-minute bottles to 45 or 50-minute bottles because wouldn't it make more sense for us to have more air? If I can put 45 minutes of air or an hour's worth of air on a firefighter's back, then man, that's so much better, because now if they go down, think about how much more air they've got. Think about how much longer they can work before they have to come out and change out bottles. Perfect world, perfect scenario. It sounds great, right? But the problem with that is that we know that now the firefighter who was maybe wearing 50 pounds worth of equipment is now wearing 60 pounds of equipment because that air pack weighs 10 more pounds. So how much quicker are they going to fatigue? A firefighter who used to have to come out after 10 or 15 minutes of working wearing a 30-minute SCBA, now they're staying in there for 20, 25, 30 minutes. What kind of impact is that having on their health? What kind of impact is that having on the injury rate? Because we're not giving people adequate amount of time to rehab. So again, we have to, bigger isn't always better. More technology isn't always better. We've got to balance that whole thought process of, what's worked, what the tradition is with the science and what the science is telling us and what technology can do for us. Certainly, I think we're better off with technology than we are without it. I wouldn't have a podcast if it wasn't for technology, obviously, but at the end of the day, I think that sometimes we rely too much on technology and we lose, we kind of get rid of some of the common sense thought process that we historically have had in the American Fire Service. So there has to be a balance between real world experience and the technology, bring it together. So next myth is, our PPE makes us invincible. Been a lot of different iterations of turnout gear and PPE, just in my career, let alone the history of the American Fire Service. We've back in the 80s and late 80s, early 90s, we went from 3/4 boots to bunker pants and coats. Night pants is what they were often referred to early on. You still wore your 3/4 boots during the day, but when you went to bed, you had your bunker pants, essentially are the equivalent of what we have today. They were called night pants because you could get them up and put them on if you were sleeping in a pair of shorts or your underwear or whatever in the firehouse or at home or wherever you were sleeping. But anyway, we made those changes. We used to not wear hoods. We used to wear rubber, cotton gloves with rubber coatings on them and things like that. Our fire gear has certainly evolved. We've got vapor barriers in our gloves, which we didn't used to have. We've got added insulation. We've gone from no Nomex hoods to Nomex hoods to PBI to carbon fiber to now we've got the new hoods that are supposed to help with carcinogen exposure on our neck and jawline and everything, where we know that the absorption rate goes up so much more when we're hot and sweaty and that sort of stuff. So, a lot of that stuff's good. Again, it's trade-offs, right? A bunker coat and a set of three-quarter boots weighs a whole heck of a lot less, particularly an older bunker coat, than a modern set of turnout gear. Um, so we have to be cognizant of that. I always tell people that, or explain to people how a lot of people don't understand how fire gear works, right? Fire gear is not necessarily designed to reflect the heat away from you. Yes, it will reflect some of the heat, but the way fire gear is designed to work is the dead airspace in between the different layers of the fire gear. It's no different than a sponge. When you think about, you have a sponge in your sink and you stick it down in the sink that's full of water. The sponge fills full of water, but it can only hold so much. If I've got a sponge the size of a brick and I've got 4 gallons of water in the sink, it doesn't take a brain surgeon to understand that sponge can't absorb that 4 gallons of water in the sink. It's the same concept with our fire gear. Our fire gear technically acts like a sponge, right? That's what that dead airspace is. But instead of absorbing water, it's absorbing heat. But at some point in these fires that we're in, it's the same as having that brick-sized sponge and 4 gallons of water. We have our fire gear, but there is so much heat that it can only absorb so much heat. And then when that occurs, we have to do something. We either have to cool the environment, or we have to exit, because otherwise we're going to get ourselves in a world of trouble. So we're not invincible in our fire gear. Certainly, we're much better protected than we used to be, but we need to be cognizant of what that fire gear is doing for us, and I'll put the SCBA in there as well. We still marvel at some of these firemen, these stories you read about guys that made rescues 30 or 40 or 50 years ago, and they didn't wear SCBAs, and they would go in, they would crawl in, and they were wearing three-quarter boots and rubber long coats or whatever they were doing, and no hoods and everything, and the reason that those guys could do that was because they were fighting those fires that were the majority were naturally occurring materials burning: cotton, wool, wood, feathers, horsehair, wood shavings, whatever it was, right? They were all naturally occurring materials. They weren't those synthetics. That's a lot of the reason why those guys got away with that stuff. Not to mention that they were taught you got to stay low, and a lot of our folks, even though you get taught stay low, I see it all the time. People just go walking in because I've got this SCBA on, and I don't have to stay low because I can breathe in the air. And then 30 seconds later, 10 feet inside the front door, they fall through the floor because they weren't paying attention and they missed the hold because they couldn't see their feet. But that's another myth I'll get to here in a second. But we've got to make sure that we're not overextending beyond where our fire gear can take us. Certainly our fire gear is good. It's better than it's ever been. But as I mentioned earlier, there is a trade-off between advancements in technology and equipment outpacing some of our own common sense and being able to use that space between our ears to actually think about what we're doing and not get so focused and tunnel visioned on something that we make too deep a push and we realize, oh crap, I've used 3/4 of my air or half my air, and I'm in too far. I'm not going to be able to get out before I run out of air. Or, oh shoot, it's getting really hot in here and I'm not sure where the closest window is, and I don't have any water. Maybe I'm searching or whatever. So we've got to be cognizant of that. Don't take our gear for granted and think that just because we're fully encapsulated in our fire gear that we're invincible. Myth number 8, I mentioned it just a minute ago. If you can see your hands, you're good, right? Or if I can see my feet, I'm good. It's not always the case, right? Conditions can go to crap in a hurry. I always tell people, get down. Now, if it's completely clear, or if there's just a really, really light haze, um, I get it. I'm not going to be in there crawling either, or not, or tripoding, or duck walking, or however your department does it, or however you do it individually. But at the same time, if it's borderline, yeah, I can see my feet, but it's kind of, I can't see them clearly. It's a little bit smoky down there. Just get out. I can't begin to tell you how many, honestly, how many people I've seen over my career fall through floors, or they got all their weight, they or not fall through. Well, they have fallen through floors, but fall through a hole because they walk in. They're like, oh yeah, I can see my feet, and they're looking around and everything else, not realizing that the smoke conditions are getting worse as they're advancing in, or the smoke conditions are just bad enough that they can see their feet moving, but it's thick enough that they missed the hole in the floor. Or if they would have been down and been out on one, in a tripod or lead leg forward or something, whatever you want to refer to it as, and sounding and sweeping that floor out in front of them, they would have noticed the floor dropping, or they would have noticed it getting spongy, um, or their foot would have gone through the floor or found the hole before their whole body did. So just because you can see your hands doesn't, or your feet, doesn't mean that you're good. Get down. Things can go lights out really quick. Somebody um, opens up a hand line and pushes some of that smoke and heat down on you. Somebody ventilates incorrectly. A window fails on its own from exposure to the high heat. Wind shifts. It could be any number of different things, but things could go from relatively good visibility or so-so visibility to lights out in a hurry. And if you're not maintaining your orientation and you're not maintaining your situational awareness, you can turn around and bite you in the butt pretty quick. Myth number 9, fast water fixes everything. Certainly putting the fire out, if the fire goes out, everything gets better. I can't argue with that, but the key takeaway from that is if the fire goes out. If I'm just spraying water and I'm not hitting the seat of the fire, then at the end of the day, I'm just spraying water. So we've got to make sure that we're getting our hand lines where they need to be, and that we're hitting the seat of the fire. If we've got fire in a room and we've got, it's coming out of that room and wrapping around the door out into a hallway. If we're flowing water and all we're doing is spraying water in the hallway, we're not solving the problem. All we're doing is prolonging the problem. We've got it. Just because you're putting water on flame doesn't mean you're putting the fire out. It might just be those fire gases that are exiting the room and coming down the hallway, or extending from around a corner or something. So you've got to get the water where it needs to be and coordinate. Particularly if you're flowing two different hand lines, the hand lines need to coordinate depending upon how your department operates. If you have a primary attack line and a backup line, then that's oftentimes a little easier to coordinate because the attack line is going to be up front and the backup line is going to be behind them somewhere, protecting him in the event that fire gets behind them or um, pops out somewhere that it wasn't expected or whatever, or the attack line loses water for whatever reason, pump problem, busted link to hose, hydrant goes down. It could be a number of different things. But if you don't run the primary attack line and the backup line, then you've got to coordinate even more so. You don't want opposing hose lines. You don't want folks spraying water where it doesn't need to be sprayed. Um, things like that. It's important to understand the importance of intelligent water application. It's not just a matter of just stretching a hose and opening it up and everything gets better. There's a method to the madness. There's a technique to it. So we have to make sure that we're doing that appropriately. The idea of flow pass. I haven't mentioned flow pass specifically today, but it's important to understand because when we open up a door to make entry, particularly, most of the time we're going in a front door on a lot of fire attacks. And we've created a flow path. And I always remind people that, we were taught in the different firefighting manuals, and you'll read it in plenty of fire ventilation articles over the years, that the standard size ventilation opening for a residential structure fire is 4 feet by 4 feet. If you're going to cut a hole in the roof, it needs to be 4 by 4, which is 16 square feet. But without going into great detail about the size of those holes, we know that, again, that's one of those myths that have passed through the American Fire Service from back in the 30s or 40s or 50s, whenever that um, dimensional size was first recommended, because they were fighting fires with materials made out of naturally occurring items, right? We know nowadays a 4 by 4 vent hole is probably not big enough. 6 by 6, 8 by 8. Some people say you can take the whole roof off of a home and it still wouldn't be big enough. It would still be a vent limited fire. So, but again, that's one of those myths that has passed through how many generations of firefighters up to modern day, the 21st century. We're using these 20th century tactics with ventilation openings to fight 21st century fires. And that's one of those examples where our tactics haven't caught up with the environment that we're working in. But to go back to the attack line I was referring to, so we know 4 by 4 holes, 16 square feet. When I open the front door, I create over a 19 square foot opening just by opening the front door. Most doors are about 6 2/3 in height, by 3 feet wide. You can do that math, and you'll see that that's about 19 and a half, between 19 and a half and 20 square foot ventilation opening that you've just created in the side of the house. So it's almost 25% bigger than the recommended vent hole size that we're supposed to cut in the roof. So we have to be cognizant of that when we're stretching. Don't stretch dry. I've seen it done. I've hear of departments that do it. Don't stretch dry, because if you stretch in, you open a door and you're stretching a dry line down a hallway, and it takes you a minute or two to get locate the fire or to get water or whatever the case might be. That whole time that you're doing that front door's wide open. You've completed that circuit. You've got a flow path now, and that fire is going to be coming out that door eventually. So even if you stretch with a charged line, which is best case scenario, you've only got a limited amount of time before you cross that threshold to get in and find that fire. Just because you've got a charged hose line, you're wearing your fancy pants, PPE, and your SCBA, doesn't mean that you can lollygag around. If you're having trouble locating the fire, let somebody know. Stop and listen. Don't just randomly start crawling around. Feel for heat. Or listen for popping and crackling or any other sort of noise that might tip you off to where they're breaking glass, things like that, to where the fire might be, so that you get the water where it needs to be. So, myth number 10, which I just kind of opened up to it with myth number 9 about your time. We know that fires nowadays can flash over. The standard rule of thumb is 3 to 5 minutes. Depending upon the size of the room and the fire load, it can happen a lot faster than 3 to 5 minutes. It can happen in a minute and a half to 2 minutes. So you have a very limited amount of time. So and we have more time than our fire victims have. So we have to be cognizant of that. We have to make sure that we're doing the most good for our victims, because they don't have 3 to 5 minutes. They don't have typically 2 to 3 minutes. It's a minute or two is going to make the difference between them surviving and them dying. In a toxic atmosphere, with temperatures increasing, and oxygen levels decreasing, we know that it's imperative that we get in and locate those victims as quickly as possible. So, not only for ourselves, for we don't have a lot of time between when we break the seal on that building, or if it's already been broken before we get there. If windows have failed or fires burning through the roof or whatever the case might be, that seal has already been broken. That just compounds things. So Time is of the essence. We don't have a lot of time. Um, I'm not advocating for running and sprinting on the fireground, but I see way too many fire departments. The guys get off the truck and it's like, oh yeah, I've been here before. I've done this. I'm going to look cool, slow walking up to the front door because I want to look like I'm a cool fireman. But you wouldn't want somebody slow walking up to your house if your wife or husband or child was in there. You'd want them showing that they gave a crap, right? Act like you want to be there. Act like you're there to do the right thing. Put a little hustle in your step, a little pep in it, and make a difference. Don't just lollygag. So, as I said, I'm not a runner on the fire ground. Never have been, but sense of urgency certainly comes into play here. So I see people taking way too much time. The other point to the myth that we've got plenty of time because of our fire gear and our SCBAs and everything else is lack of training, lack of practice. If you make a shitty stretch, if you make a stretch that it looks like a spaghetti bowl, um, you're certainly hurting yourself because it's just going to make advancing that hand line a lot harder. But now you're hurting the homeowner financially, the insurance company financially, and potentially the homeowner physically if them or one of their family members is still inside the structure. So train, practice, because we don't have an unlimited amount of time. And we want to be proficient at our job, look like we've got the training that we need, we've got the equipment we need, and we've got the ability to do the job that we said we do. So in closing, I'm not going to recap all those myths, but I would just challenge you to sometimes when you hear somebody say, "Well, this is just the way we've always done it," or I saw this video where they did this ABC whiz bang technique, and man, this is the only way we're going to do RIT drills or RIT training from now on because man, look, they built this harness and they did this and they did that, and it worked, right? So, but they probably weren't doing it in zero visibility. They weren't doing it in a high stress environment. They probably weren't doing it in a high heat environment. It could be a number of different things. So I'm not saying to constantly challenge people, but you need to stop and step back and ask yourself why, or ask the person who's saying, "Hey, this is the way we're going to do something." Why? Not to be confrontational, not to be disrespectful, but for context and understanding. A lot of times, hopefully, they're going to have a justification. But if their justification is, well, this is just the way we've always done it, that may not be the best way to do it. So you've got to be realistic about that and stop and think about what you're saying and what people are telling you. Um, be your own advocate, do your due diligence, be respectful, follow orders. But at the end of the day, um, try and identify some of those myths yourself and maybe work to dispel them so that we can continue to make the fire service better. So um, with that, I'm going to wrap it up. Again, my name's Eric Dreiman with the Hooks and Hoses podcast. I want to thank Fire Engineering and Fire Engineering Network, Dave Rhodes, Diane Rothschild, Mark Hall, who's the guy behind the scenes that edits and produces a lot of these videos, along with Peter Pacillo for Fire Engineering. Have a good August, and by this time next month, when I do my next episode, we'll know who else is going to FDIC 2026. So good luck to those who submitted proposals, and hopefully you'll get selected. See you next month. Everybody take care.